What's up, everyone? Welcome to the podcast, Finally, a reason to use my psych degree. With your favorite college graduate, Caitlin, with this week's episode, AI Takeover. Hi, hello, how are you guys? I hope you're doing well. So a few weeks ago, I went and saw that movie Free Guy with Ryan Reynolds, and I find myself fascinated by the idea of a non-player character, an NPC, being able to take on its own identity. This is possible due to artificial intelligence. Although AI is more of an engineering topic, the concept of software being able to learn and create new ideas is what really excites me. It's like software is able to create its own personality. AI refers to a simulation of human intelligence in machines that are programmed to think like humans and mimic our actions. And this is where machine learning comes in. Machine learning is a subset of artificial intelligence. It's that system that provides the software to automatically start to learn and improve from experience without being explicitly programmed to. Do you remember my previous episode about pareidolia, the phenomenon regarding the ability to notice a face out of everyday objects? Well, during my research for that episode, I found something kind of interesting, and I thought it deserved an episode all of its own. We're familiar with facial recognition. It's how I open my phone, access my Apple Wallet, and pay for most things nowadays. Facial recognition was able to come about because of machine learning. The software was programmed and learned to recognize your face based off of numerous trials, learning what a face was and a face was not. A man named Phil McCarthy wanted to test this a little bit more. McCarthy combined random polygon shape generator and facial recognition software. The polygon software was able to create all of these mismatched shapes and just push them all together. And then he had the facial recognition software take a look at it. And the software was able to recognize faces out of these shapes. And I mean, if you look at these, they clearly look like faces. I mean, if you go back to that first episode, this is exactly what I'm talking about. And we can label this as pareidolia. However, this means the machine can sense that too, meaning the software could also create false positives. Now, this rarely happens, and in one trial study, only 7% actually notice these as faces. But that's where I went down a rabbit hole. Humans are inherently biased. We can't help that. But does that mean our software, our AI, and our machine learning are too? We created it, so wouldn't it hold the same true values? What is AI bias? It's an anomaly of the output of machine learning. This could be due to prejudiced assumptions made during the algorithm development process or prejudices in the training data. And there's many ways AI can be biased. The first one is sample bias. This is when a data set fails to reflect the realities of its real-world environment. An example of this is facial recognition software primarily being trained on photos of white men. These models then have a lower level of accuracy for women and people of different ethnicities. Another name for this is selection bias. The second one is exclusion bias. Most often, this is a case when values are deleted because they're considered unimportant. An example of this, imagine you have a data set of consumer sales in America and Canada. The data shows that 98% of the consumers were in America. So the data will delete the 2% of Canadians just because they thought it was irrelevant. The third one is measurement bias. Collected for training may not be reliable or reflective of the actual data and lead to faulty measurements, leading to data distortion. An example of this can be used in image recognition data. This is where the training data is collected off of one type of camera, but the production data is taken off a different, leading to distortion in what the data actually is trying to read. The next is recall bias. This is when you label data irregularly too many times, which can lead to lower accuracy. For example, let's say they have a software to determine if your iPhone is considered broken or not. And there's 3 levels: broken, partially broken, and undamaged. If someone labels one of them as damaged, but a similar image is labeled as partially damaged, your data will be inconsistent. Next is observer bias, also known as confirmation bias. It's the effect of seeing what you want to see and expect to see. This can happen when researchers go into a project with a subjective thought about their study, either conscious or subconscious, resulting in inaccurate data. The next one is racial bias. Now, this isn't a bias in traditional sense, but it's still worth mentioning because of the level of prevalence it has in AI recently. Racial bias occurs when data is skewed because of particular demographics. This can also be seen in facial recognition software, which can fail to recognize someone of color as accurately as it does with someone who's Caucasian, which also links to association bias. This bias occurs when data in machine learning reinforces or multiplies a cultural bias. So let's say your data set has a collection of jobs in which men are doctors and the women are nurses. That doesn't mean that women can't be doctors and men can't be nurses. However, as far as your machine model goes, female doctors and male nurses don't exist. And these biases affect us way more than you think and can be easily overlooked, which is the scariest part. Here's some real-world examples of when that happened. Amazon started an AI project in 2014, which was to automate the recruiting process. Their initiative was to primarily focus on analyzing resumes and evaluating candidates using AI-powered algorithms, allowing recruiters to spend less time on human screen resumes. But by 2015, Amazon had recognized that it wasn't working properly. It was actually being discriminatory towards women. Now, this model was created using 10 years of data that Amazon had collected on their hiring process. However, because the computer industry has been so heavily male prevalent, and in their data, 60% of the workforce was made up by males, the historical data had bias against women. As a result, the Amazon hiring algorithm made a mistake and assumed that male candidates were better suited for the job. Amazon no longer uses this algorithm. And in 2019, Facebook enabled marketers to target advertisements based on gender, ethnicity, and religion. So if you can guess, employment advertising for nursing and secretaries went more to women, whereas minority background men were given advertisements for taxis and janitors. Again, Facebook no longer allows marketers to target populations like this. But as you can see, this is a real problem. So are artificial personalities flawed forever because of the creators? Can we live in a world where AI can overlook our human biases? Technically, yes, but not anytime soon. An AI system is only good as its data. If you clean the data set of conscious and unconscious bias, you're able to build an AI system that can make unbiased, data-driven decisions. However, right now, that's not a reality. AI can only be as good as the data, and people are the ones who create data. So what can we do? Well, to minimize bias, we have to perform tests, and a lot of tests on the data and the algorithms. And as far as my knowledge goes, that's all I've got. However, with computer science growing so much in need and popularity in schools and in employment, I don't want you to forget this. Don't overlook your algorithm. Test your data, and then test it again. Treat your AI as Guy. Help him grow up in a world where the possibilities are endless and your biases are slim to none. Thanks for listening to my podcast, finally, a reason to use my psych degree. Stay tuned next week to see if I can find another.